Hi there, my name is Tina, and this is the section on synthesis of gates. Okay, so in your class, you're going to be spending a lot of time on VHDL. Don't know if Dr. Benson's going to do Verilog, but either language is there to really enable you to make some really complicated circuits in a matter of seconds. It's very powerful just to be able to write a line of code and then push a button and have an actual chip. So chips you've seen on boards, for example. I don't know if this is going to show up, but here's a chip. So that one line of Verilog or VHDL, you can push a button and brings it down to the files. Sorry, I have bike grease on my finger. Brings it down to the files that you can send out to a fabricator and actually build your chip. Okay, I'm going to show you just a couple of steps of that. We don't have time to go through the whole thing, but yeah. So with Verilog and VHDL, if Verilog and VHDL are so powerful, why would you not want to use them? Okay, so I've been talking a little bit about gates. The reason why you would like to design in gates sometimes is that with Verilog or VHDL, you do not have control of speed, area. You can't optimize them, speed, area, or power. Those are important things when you're designing a circuit. So if you want to optimize any of those, then you have to go down and you have to be able to design in gates. Okay, and gates are if you were able to take a gate and crack it open and look inside of it, you'd see transistors. So gates are the next level above transistors. So if you've designed in gates, you've basically already designed in transistors. Okay. So I'm going to show you just an example of a tool that you would use to take your design in Verilog or VHDL and sorry, I'm not good at multitasking, and turn it into silicon. Okay, so I'm pretty sure you can't see this, but here's a simple program in Verilog, and all it's doing is let's see if my finger can do this. Right there, prod. I'm multiplying A times B and putting the result in prod. And A and B are 16-bit numbers. 16-bit numbers. So it's actually a decent sized number. Okay, and that's one line of code. So one line of code and you're done in 5 minutes. Okay. What happens to that is before it can go into silicon, it has to be turned into gates, and then after it's been turned into gates, it needs to be turned into transistors. And here's the input to that circuit that I just showed you. Here's the output. If you go over here, you can see the hourglass is going on here. So it's taking that one line of code and it's turning it into gates right now. And this step is called synthesis. And if you work at a company where that makes circuits, digital circuits at this point, you'll be using a tool like this where you put your code, your VHDL or Verilog into it, and it turns it into gates. So this is the result of that code that I just showed you. And you can see here, you can see AND gates and OR gates and NOR gates, and once you have this, and you can see how much of a chip wires dominate, and that's another really big thing that's going on right now. Transistors have gotten so small, and you can't make wires smaller. Anybody interested in that can email me. Can't make wires smaller, so these days chips sometimes are just dominated by wires. You have some circuit stuff, but then all the rest is wires. Okay, so this is just an example of what happens to your VHDL or Verilog before it turns into a chip. It needs to be turned into gates, and then each one of these gates, there's another piece of software that turns those gates into transistors that I won't show you this time, but take EE431 if you're interested. And this single design here, when all is said and done, was about 100,000 transistors. And notice we just did that in a matter of seconds. Okay, that's the end of the video on synthesis of gates from Verilog or VHDL.